Now in this tutorial, we'll learn how Spring Framework achieved the inversion of control, as it is a IoC framework, which means it leverages the inversion of control principle heavily. So when our Spring Boot application starts, it scans many parts of our application, including the class path. Based on what the application finds, it automatically adds Spring beans to our application context. You have to understand clearly this line, because the application context and Spring Bean are two crucial things of Spring Framework. So what is application context? Application context is some kind of container which start at the beginning of our Spring application, whether or not Spring Boot is involved. When our Spring Boot application start, it creates some kind of container, and that container is called the application context. So the application context have some other name like Spring container, Spring IoC container, etc. So this is actually an interface. If we go to the application context interface, which comes with the Spring framework, as you can see here, this comes with Spring context, and under the package org.springframework.context, here this application context is the context we are talking about. This is the Spring IoC container, also Spring container, whatever you say. Here, as the documentation says, central interface to provide configuration for an application. Okay, this is the default IoC container for Spring Boot application. It also extends some other interface like listable bin factory here, and if we go to the listable bin factory, you can see that this interface extends some other interface called bin factory. Here the bin factory is another application context sort of thing which provide the very basic functionality for creating and managing bin, but our application container is the main IoC controller. Okay, now we understand that Spring application's application context initiates at the beginning of our application startup, and it is some kind of container. It scans for Spring Bean and registers them in the container. So now let's understand what is Spring Bean. We know that Java Bean are plain old Java class which have some property, private property, and those properties are accessed via the getter setter method. Spring Bean is an instance of Java Bean which is maintained by Spring container. So Spring Bean is just a Java Bean which is instantiated, assembled, and managed by Spring IoC controller or our application context. So when our application start, our application context scans for the Spring Bean and register them to the application context. Now, how Spring Boot understand that this is a bean, this is a Spring Bean? Since Spring Bean is an object that is managed by Spring application context, the classes which are annotated with @controller, @repository, @service, @component, or a class which is annotated with a configuration annotation, and it also have a method with bean annotation, and that method returns an instance of a class. Those are the ways a Spring application understand that this is supposed to be a Spring Bean, and I have to add this to our application context. So when the application start, it scans for this kind of classes which are annotated with those annotations. So now let's understand how Spring application achieved the inversion of control. So now that we understand the application context and bean, let's imagine our application started scanning for the bean to register to the application context. Here one class which is student service, this is annotated with service. So Spring will register an instance of this class as a Spring Bean. Okay, so one thing I want to mention here is by default the scope for a bean is singleton. So the instance or an object which is registered to the application context will be available throughout the life cycle of our application because it is singleton and only one instance is available. Spring Boot scans for this class and want to have an object of this class as a bean. So when it want to instantiate this class to have an object, then we can see that in the constructor we have passed the student repository here. We did this because we want to focus on the implementation of student service rather than manually creating the database connection and handling all the persistence logic. We want to have those persistence logic injected in this class, and we want to focus on the student service. So we designed this way. So when Spring Boot application start, when it want to have an instance of this student service class as a bean, then it find out that it have another dependency, and again it asks the application context, do you have the instance of this student repository? If you have it, then give me that, or create one and then give me. Application context either have it or create a new instance of student repository and return it, and this way the instance of student service is registered to the application context as a bean. So this is how Spring Boot achieve the inversion of control. Spring Boot can achieve the inversion of control with dependency injection here, which is a constructor based injection. We can also just put an auto add annotation. So this is one way we can achieve the inversion of control. I hope you have understood the idea how Spring achieve the inversion of control and how Spring register all the beans to the application context. Now you may ask, why do we need this? We can just create new instance of student repository in the class. Why do we need this kind of architecture where application scans all the component and register to the application context? The answer is, for the standard situation when we need to power up our application in the live server, we want to make sure that all the beans are wired up as expected, and since beans can have different kind of scope, we can apply the scope as we need. So I hope you have understood the idea how Spring achieve inversion of control and dependency injection. I'll see you in the next tutorial.